Now let us come to stage two of the solution to the problem of traffic light. And yeah, before getting into this one, I just wanted to recap on ADT, which is abstract data type. So abstract data type is something we have to think of that what kind of data type from the mathematical model we will take it up, and we will try to write a pseudo program around it. Okay, so important part over here is that how to use an abstract data type. So abstract data type is something which we think of, and we will find out that how that ADT or abstract data type is being implemented in any programming language, or how we can use the language construct of a programming language to use or to implement our ADT in that form. Okay, so here in the stage 2 we will write the general statement of the algorithm, and we will try to find out, we will try to give a solution around it, and then we will refine it into the in the next phase. So when I'm talking about ADT, how it is implemented, here we have taken abstract data type as graph or list. Okay, so list is one kind of a data structure. Sorry, it is a ADT, which is like a which will create a graph around a graph kind of a thing, create a list to hold the vertices of the graph, and we will keep all the statements how to run the program. We'll write the program. Okay, when we are writing a program like this, it is any kind of a programming language. I just put it across over here like this. So don't take it so this one so neatly look into that. It can be any kind of a programming language you can use. It is a I have written like a functional programming. So grid assigns new color to set of vertices of the graph that may be having the same color. So this is the first thing that we are going to do. So here, what I'm trying to do is that there is a graph which is kind of a list which hold all the vertices of the graph, which is like all the turns, which is permissible turns. These are the permissible turns: A, B, A, C, A, D, B, A, B, C. All these things are permissible turns. So those turns are being listed down in a list. Then color create a list to hold all vertices after it is being assigned. So this is a list which is empty, and we will add those vertices after having that colored. Once a particular vertex become colored, we will add that to here. So initially it is empty. So let us look at this simple program. I mean to say simple algorithm. Like for each uncolored vertex v into g in G. Okay. So here we have G, that is graph, which has all the vertex which is uncolored for first time when you go into that one. So all the vertex are uncolored. So you for each vertex which is uncolored. So means once it is colored, it will be not taken up. So we will check that if any vertex that is colored. If V is not adjacent to any vertex in the new color. So in new color we have all other vertex. Right now initially there will be nothing. Okay, there will be nothing. So V is not adjacent to anything. For example, if I'll go to here like AB, then it will tell me that AB is not adjacent to any of the vertex that is in new color, which is there is nothing. So it will color that V with a blue color, and then add V to the new color, and it will come to the next one. Then we will go to the next one. For example, we will go to AC, similarly AD. So when you go to AC, then again check it out, like AC it comes. Okay, is AC is there in the new color? No, only AB is there. And is it AB is adjacent to that vertex? No, so it is colored again. Likewise, if you are coming, you come to BC, for example. Okay, through this way you come to BC. BC, we'll get into BC. We get VC from graph G, and V is not adjacent to any of the vertex in new color. Okay, now in new color has AB, AC, AD, and BA. Is BC is connected to AB? Yes. That's where we will come to know that it cannot be colored as blue. Now it will not the same color. So because there is a earth between AB and BC, so simultaneous turns are not allowed in for AB and BC together. So let us check here. Is it true? AB is like this, right right side, it's coming to right side. Now it is BC is B is right, then going into the right. So this is simultaneously not allowed. So that is exactly what we have written over here, is that AB and BC. When BC comes, BC will not be colored as ABAC, AD or BA, which are colored in blue, because there is a edge between AB and BC. That's how the program has written. Similarly, it will go for all the colors, which is blue. Then it will go to the next color, that is green. Then it will go to the next color, like yellow. So like that, there will be three or four colors we will take, and using those colors, we will color code all the vertices, all the turns is actually. So those turns will be colored, and based on the color, we will allow the traffic to move. Okay, now as you understood writing the program in the simple informal algorithm, now let us move to write in a specific programming language. We'll try to use that programming language as much as possible. And wherever is we don't want to write, and we can very well write some kind of a again informal statement, and we will refine that again. It is a stepwise refinement, so we will refine it further. But it is most importantly, we need to understand here ADT, that is abstract data type, that we have initially created, or maybe we will try we are trying we started using that one in the first phase. We will try to use that we will try to use that in programming language. The most importantly, we need to understand any abstract data type, how it is being implemented in a programming language. That is the data structure we will be using in this particular program. So the important part over here is that the abstract data type, how it has been implemented in the programming language. We will try to understand that, then we will implement that. So ADT, which is like abstract type thing, we thought it is a list. Okay, so how the list is implemented in particular programming language, that we have to learn. So that will be there, but the concept of list will remain same. Okay, so let us go to something called list. How the list look like? Let me show you something, which is like this. Okay, this is what the list is all about. Okay, see, this is a list is having two parts. One is like storing the value. The other is pointing to the next cell. So it is holding all the information in cells. It is a concept. Okay, here the first cell contains header. It will not have any value, it will have a header, and some initially this part, the pointer part will be null, because they don't hold any value. Once we have a value like this, okay, there's a 4 something like that, then we understood what is the pointer or the address of this particular cell, and use that address or the pointer in the header. So header will have a pointer which will mark to the next cell, which is this particular cell. Similarly, this cell has value, the next part is the pointer. When you don't have any value like this, the other side, then this part will remain null. But once we have a value over there, then we can have the pointer to this particular cell which is holding a value. Again, you can see here it is null. This is how the list data type usually being understood by concept, not by structure. So how in structure it is being used is something we can look into that one. But this is how. But what are the operations we can do in list, is that either we can add or append a cell, or we can add a cell between these two. To adding at that cell, this pointer will be moved to the cell that we are inserting, and the insertion cell pointer will be copied over here, so that this cell will point to the cell that we are inserting, and this inserted cell will have the pointer, this pointer there, so that will point to this one. So it will go like this. Look at this point, there is a insertion. Deletion, you can delete this without any issue, and we will delete this pointer and mark it as null. You want to delete this part, then you delete this part, and this pointer which is pointing to this one, because this is still alive, this pointer will be copied over here. This will be copied over here. So this will directly point to this one, and this is gone. This is the concept of list, basically, where we can modify, we can delete, we can add, we can append. Okay, all these operations can be done on the list data type. So same data type, how it has been implemented in data structure, which is a data structure in programming language. Sometimes this being either directly as a list, and sometimes it is different ways of implementing it. In this case, if you look at we can create list to hold values, but what we can do is that we can also use array to hold those values as well. So it is not necessarily an abstract data type which is defined here as a list has to be created as a list only. You can think of that list. I want to implement this particular list as an array, this list as a set is different. Basically it is a mathematical understanding of the concept. So once you have that one, then you come to programming language and you saw that list is something which is not available. Then you will formulate that how it can be implemented there in that particular program. So you come to the next level, refined level of program is like in this one we are refining it from the previous one, is a more programmatic approach. Here what I am doing is that I created a list of vertices. I have created a list of hold all the. Okay, here we have created the list that holds vertices of the graph. Then we can have another list, okay, which is holding the edges as well. List, okay, edge, create list to hold all edges of the graph. Because that is something which is we think that you may not be able to keep it at one place. So that is something we require. So what we created is that a edge that is we have created. Okay, we have created the edge. So that edge we are going to keep that one. And again new color, once it is assigned, color is assigned, we can have that one. Then new color is empty. If it is found, then integers v and w to hold the vertex as well as the new color. And we'll come here and check if there is a edge between v and w in graph, that we will search in check in edge. So you check in this one, this edge. There is a, if there is a edge between. So let us go one by one. Okay, we have to declare this. V is the first color uncolored vertex. You take that one. Okay, is V is not null. If it is not null, then you'll go. So till the end, we get the vertex. We'll go through this one. Then W is same thing. Vertex in this one. If it is not null, we'll go into this one. Okay, if there is an urge between v and w, so first v we have taken, and there is something in the vertex, so we will take these two. We'll see if there is a link between these two, if there is a urge between these two. That is what we are checking. Then found true, then go to the next color. Okay, if it is found, then it is not possible to color that. Then next color. If found false, okay, if found false, then only we will do B as colored and B is added to the new color. This is what we'll go through everything. But at the end, what we have to do at the end, so you'll go one by one, all those vertices which will not have any edge with the W, that I mean any the color, those vertex which are there in the new color, it will check in the first round, it will make the mark it as blue. Now there are vertex which are marked as blue and they are moved to new color. What you have to do here, either remove or color vertex and edge which are, edge is nothing but pair of vertex. Okay, edge is nothing but, let me note down here. Okay, okay, edge is nothing but pair of vertex, okay, which has a edge between these two. So edge between these two is done. Remove or color vertex and edge which are colored. Okay, those vertex which are colored, any uh, any value that is having edge with that vertex, which are color. Remove or filter. The color vertex and edge, or the vertex. Something is wrong. Okay. Okay. Remove or filter the vertex and edge which are colored. Okay. So which are vertex is colored? If any edge between that color with any other remaining one will be removed. It should be removed because anyway those colors, those who are colored with blue color, will not have any edge between them, but they will be having edge with other vertex. So those things has to be removed. That is what we are removing over here. And then go to the, we will go to the next uncolored vertex and we will go through the same thing, and this time we will color with green. So something I have just written in the algorithm or general statement, but this is something what how we have to refine into the next level, and probably will even refine more. But remember that whatever we are writing over here is a functional programming. It's not object oriented programming. This is more of a functional programming. We will try to do it in object oriented programming when we will discuss that object oriented concept. There we will try to find out what can be the object here and how the operations can be built into this traffic light program so that it can be written as a object oriented programming as well. Okay, thank you.